Namaste children, how are you all? I hope you are fine and welcome to today's math class. Today we are going to discuss about surface areas of solid shapes. What are solid shapes and their faces, their vertices, edges we studied in the previous chapter, that is visualizing solid shapes. Solid shapes are obtained by folding a two-dimensional figure, that is a plane figure, in the proper order. We will get the solid shapes. Examples for solid shapes, you see here we have a cuboid where you will find vertex, face and edge. A cylinder, a cone, and it is a cube. Then we have a pyramid is there. So these are some of the what it is a three-dimensional shape, that is solid shapes. That is a cuboid, cube, cylinder, cone, sphere, hemisphere, pyramid and prism. You see here some of the examples are given. A soap box is there here, soap box, and toothpaste box it is there you see, and a toy, that is a cube. And here we have a cylindrical cylinder biscuits packet will be there. You see they looks like what it is three-dimensional figures. Now you see the cuboidal box. You see this figure, cuboid, vertex, face and edge. What is the face? The plane figure which is made up of made up of three-dimensional figure is known as a face. Then what is edge? The line segment which joins the two adjacent faces. Then what is vertex? The point where the three edges will meet, that point is known as vertex or corner. All these things we have studied in the previous chapter. Now we are going to discuss about how to find area of these solid shapes. That is, especially we'll study here in class 8 about cuboid, cube and cylinder. So as we know, we'll discuss first cuboidal box. All six faces are rectangular and opposite faces are identical. Identical means congruent. They have the same size and same shape. So there are three pairs of identical faces. Now we observe the figure. We have these faces, top surface, bottom surface, and then we have two sides, two surfaces are there, and one front and one back. We have total six faces are there. These six faces, we have three pairs of identical faces are there, identical shapes are there. So three pairs. Now you see here the cubical box also you will find here. We have very clearly it is shown the six faces are squares and they are identical. Each face will have the same area. Each face will have the same area. Whereas in the cuboidal box, we will find same area for the opposite faces. Now you see here we have a cylindrical box is there. So one curved surface is there for this cylindrical box and two circular faces are there which are identical, means they have the same area. See, top and bottom both we have the circular bases and they are identical each other, and this curved surface is there. When we open that curved surface, we'll get it in the form of a rectangle. So these are the faces of a cylindrical box. Cylindrical box has three faces. One it is curved surface, the other one is two circular faces. Whereas a cuboid and a cube we have what it is six faces are there. So we will discuss how to find the surface area of a cuboidal box, cubical box and a cylindrical box. Is it clear, children? Now, surface area of a cube, cuboid and cylinder. What do you mean by surface area of these solid shapes? It is nothing but the sum of the areas of all the faces what it is made up of. The sum of the areas of all the faces. If you take a cube and a cuboid, the sum of all the areas of six faces is known as surface area of a cube or a cuboid. Similarly, for a cylinder, it has three faces are there. That is curved surface and two circular surfaces are there. So surface area of a cylinder is nothing but the sum of the areas of these three faces will give you surface area of a cylinder. Now you see for a cuboid, if you see this a cuboid, a box is there here, cuboidal box, where L stands for length, breadth and height. Here we have You see it has 6 faces. The 6 faces, what it is, this is a net of a cube. It is given here, the net of a cube. You see here, there's a cuboid. Net of a cuboid is given where the 6 faces are given here. 1, 2, 3, 4, 5 and 6. So the areas of the 6 faces will give us what? A total surface area of the cuboidal box. See the first box we have length and it is height is there. So its area will be what? L into H. Then second figure we have L into B is there, that is length into breadth. Similarly we have sixth figure, if you observe, L into B is there, length into breadth. And if you observe the fourth figure, again we have length and it is height is given L into H. Third and fifth figures they have breadth and height is given B into H. That is, as I said, it is the opposite faces will have the same area. So the total surface area of a cuboid is equals to, that is sum of the areas of all the 6 faces, that is area of 1 plus area of 2 plus area of 3 plus area of 4 plus area of 5 and area of 6. That is H into L plus B into L plus B into H plus L into H plus B into H plus L into B. And you see here this when we simplify this, if you observe, each figure product is multiplied 2 times, that is 2LB plus 2BH plus 2HL. So taking 2 out common, then 2 into LB plus BH plus HL will give you the total surface area of a cuboid. Total surface area of a cuboid. See here we have one more net for what it is, the cuboid, a roof, a room, it is a roof, base, and it is the 6. Total we have the 6 faces are given here. If you observe this, it is excluding the top of a room. So this is one of the figure for cuboidal box. Now we will discuss how to find a surface area of a cube. Now about cube. So as usual we know that for a cube it has 6 faces are there, but 6 faces are identical. So here they are square shaped. So area of each square shape, it is L into L, it is L square, and it has 6 faces are there. 6 into L square, it is 6L square. Therefore the total surface area of a cube, it is 6L square, 6L square, where L stands for the length of each side of a face, square face. Is it clear, children? Now how to find area of, that is surface area of a cylinder. You see here we have a cylinder with radius R and height it is H. So when we cut it vertically, we'll get this figure which is having 2 circular surfaces and 1 rectangular surface. So here the length of the rectangular surface is nothing but the circumference of the circular surface, that is 2 pi r, and width of this rectangle will be height of the cylinder, and area of each circle it is pi r square. Circular surfaces it is pi r square. Therefore area of this cylinder is equals to area of the top surface and bottom surface, that is 2 pi r square plus area of this rectangular surface, that is 2 pi r into h. So again by taking 2 pi r common, we will get 2 pi r into r plus h as the what it is total surface area of a cylinder. Is it clear, children? We will discuss in detail. So we were discussing about the solid shapes and the what it is surface areas, today's topic. And you see this is one of the example of a cuboidal box. You see this is what is the surface? It is a rectangular surface, one front and this back, both are the identical surfaces. They will have the same area. Similarly this is the top surface and it is the bottom surface. They too have the same area. And here we have our 2 side surfaces are there. These two are no, they will have the total same surface area is there. So now the total surface area of a cuboid is equals to areas of the 6 surfaces. Areas of these 6 surfaces. That is, if you consider it as say this as this is length and it is the breadth. This is the height, or even if you see this is the length, height and breadth. So area of this bottom surface, this is length and breadth will be there. Similarly top surface also we have same area will be there, that is L into B plus L into B plus. Next, if you take these two surfaces, what is this there? This is the breadth and it is the height. Breadth and height. So now area of this one will become what? B into H, breadth into height, and this surface is also will have the same area, that is B into H plus B into H plus it is then if you see this front surface we have, this is a rectangle, it is length and it is the height, L into H. Here breadth is nothing but what it is? Height. L into B means L into H, and this surface is also will have the same area, that is L into H. L into H plus L into H. Now if you observe, we have 2 are there, LB plus LB, it is 2LB plus 2BH plus 2LH, 2LH, or take 2 common, then what we get? 2 into LB plus BH plus LH square units. So this is the formula to calculate TSA, means total surface area, or simply it is surface area of a cuboid, is equals to sum of the areas of the 6 surfaces, that is 2 into whole LB, L into B plus B into H plus L into H square units. Now if you see this excluding the top surface and bottom surface, these 4 surfaces are there, front, back and these 2 sides. We call these 4 surfaces are known as lateral surfaces. Lateral surfaces. We call what it is? Lateral surfaces. Now LSA of a cuboid. LSA of a cuboid. LSA means it is lateral surface. Lateral surface area of a cuboid. So excluding the top surface and bottom surface, that is LB and LB won't be there. The remaining 4 faces are there. Therefore its area will be what it is? LH plus LH plus BH plus BH. So LH plus LH, it is there again, what we have? 2 is there common. Here it is 2LH plus it is 2BH is there. Now if you observe in this, 2 is there common and H is also there common, that is 2 into H whole into L plus B square units. So the lateral surface area of a cuboid is 2 into H, 2 times of its altitude to the what it is sum of its length and breadth, or 2 into L plus B, it is a perimeter of the base, that is rectangle, and height, it is the H stands for height, L stands for length and B stands for it is breadth or width. So this is LSA of a cuboid. So what is LSA of a cuboid? If you consider your room as a cuboid, we can see the 4 walls of the room. We can see without turning, without raising our head or without bending our head, we can see the 4 walls of the room. So these 4 walls are known as lateral surfaces of a cuboid. So its formula it is 2H into L plus B square units. So it is also known as the area of 4 walls of a room. Area of 4 walls of a room. Area of 4 walls of a room is also equals to LSA of a cuboid, that is 2H into L plus B square units. Square units. So like this we will find the formulas, and we will use these formulas to find the total surface area and lateral surface area of a cuboid. They may have the problems, find the area of the open cuboid, means the top surface won't be there, 5 faces will be there. We have to identify which faces are there, then we should apply the formula, correct formula, and we can find the area of the given solid. So now we will discuss similarly for a cube also we will discuss. A cube also we will discuss. Here it is now we can write, I am going to write it here, the cuboid, and it is a cube. For a cube it is for a cube. So TSA of a cube is equals to TSA of a cube. So now you see here, this is the net of a cube. If I fold this is a 2-dimensional figure. If I fold this in the form of in the proper way, we will get what? A 3-dimensional figure, which is nothing but the dice. Dice is also a cube. This is a die and it is a cube. You see here we have the 6 faces are there. 6 faces, all are in the square shaped. So the total surface area of this cube, even if you fold in the proper way, we will get what? a proper way, we'll get the cube. So the total surface area of this cube is equals to what? Sum of the areas of the 6 surfaces. So what will be their area for each surface? It is L, and this is also L. Length into length, it is L square. So like this, how many are there? We have 6 faces are there. L square plus 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 L square. That is L plus L square. 6 L squares are there. 6 L square units, where L is the unit of, where L is the length of each side of the face. Now TSA of a cuboid, a cube. TSA, so TSA is over. LSA of a cube. LSA of a cube is equals to, here only 4 surfaces will be there. Top and bottom surfaces won't be there. Therefore 4 L square units. 4 L square units is the LSA, that is lateral surface area of a cube. Lateral surface area of a cube contains only 4 surfaces, therefore it is 4 L square. And for a cube we have 6 surfaces are there, all are square shaped, therefore it is 6 L square. 6 L square is the square formula for to find the TSA of a cube. Now I hope you understand. Now we will discuss this is also one example for the cuboid. Front surface, this is back surface, top surface, bottom, and these two are side surfaces. A cuboidal box it is. Now we will discuss how to find TSA, that is total surface area of a cylinder. Is it clear, children? Now you take a plain paper, a rectangular shaped paper, you fold it in such a way, like this is the length of the what it is a rectangle sheet, and this is the breadth. You fold it along its length, then what we will get, it is when we fold it in the proper way, we will get a cylinder. We will get what we will get, a cylinder we will get. Clear? So like this we will get a cylinder. So what we call this rectangular shaped plane figure, this is known as curved surface. As I told here, this is known as curved surface. So here this portion is known as curved surface. So when we cut along its vertically, this is vertically, we will get what? A rectangular shape will get, that is a rectangle shape. This rectangle here, the length of this rectangle is equals to what it is? The circumference of the circular surface. This will be circular surface. So the length of this rectangular paper, what it became? It became the circumference of the circle. Circumference of the circle of radius r. So let this is length, it is 2 pi r units, and height it is h, plus area of this top circle, circular surface, circle it is radius is r, therefore it is pi r square. And here we have the bottom is there, this is base surface, top surface, and it is curved surface. We have the 3 faces. So here these two have identical, that is bottom surface and the base surface, both are identical and they are circular in shape. So area of the base or the area of the top is equals to pi r square, and this is curved surface, it made into what is a rectangle, where the breadth of the rectangle it is what? Height, and the length of the rectangle it is circumference of the circular surface. Now total surface area or TSA of a cylinder is equals to what it is? TSA of a cylinder is equals to, it is curved surface area, that is CSA, curved surface area. CSA means it is curved surface area plus area of, that is area of top or bottom, area of top surface plus area of bottom surface. So here the curved surface is nothing but area of that rectangle, that is length into breadth. Here length is equals to what? 2 pi r into breadth is equals to height h, plus area of the top surface it is pi r square, plus area of the bottom surface is also pi r square. Now it is 2 pi r into h, it is 2 pi r h, plus pi r square it is 2 pi r square. Now see here 2 is there common, pi is there common, and r also is there common. So take common, it is 2 pi r into h plus r square units. Square units is the total surface area of the cylinder. You can use this formula also, that is 2 pi r h plus 2 pi r square, 2 pi r h plus 2 pi r square, where pi is a Greek constant, that is a Greek letter called constant. It is 22 by 7 or 3.14. Now total surface area of a cylinder is equals to 2 pi r into h plus r, 2 pi r into h plus r. Similarly, CSA, that is curved surface area of a cylinder, curved surface area of a cylinder is equals to what we get, it is curved surface area means only this surface, that is 2 pi r into h, which is equals to 2 pi r h square units. So this is the formula to find CSA of a cylinder. You see here a cylindrical port, a cylinder, it is you will find here it is a cylindrical shape. See here bottom we have what, a circular surface is there, top also we have a circular surface, and this portion is known as what, curved surface. So area of this cylinder is equals to area of the bottom surface plus area of this curved surface plus area of the top surface, which will give us what it is, 2 pi r h plus 2 pi r square units, or 2 pi r into h plus r square units, and CSA of a cylinder is 2 pi r h square units. Now with these formulas we will solve some of the questions. Is it clear, children, the formulas how we derived? Yes. Now we will discuss an example. Find the TSA and LSA of a cuboid whose dimensions are length is 5 centimeters, breadth is 4 centimeters, and height is 3 centimeters. TSA means total surface area. LSA means lateral surface area. So first write the given measurements. So what are given here? Given measurements, it is length L is equals to 5 centimeters. Then breadth B is equals to 4 centimeters, and height H is equals to 3 centimeters. Now TSA of a cuboid. So what is the formula to find TSA of a cuboid? Yes, it is 2 into LB plus BH plus LH square units. Now substitute those values in the formula and simplify. Here L is equals to what? 5 into B is equals to 4 plus B is equals to 4 into height H is equals to 3 plus L is equals to 5 and H is equals to 3 square centimeters. Now you simplify, that is 2 into 5 into 4 20 plus 4 into 3 12 plus 5 into 3 it is 15 square centimeters. That is equals to 2 into 20 plus 12 32 plus 15 it is 47 2 into 47 square centimeters. Now multiply with 2, that is 2 sevens are 14, 2 fours are 8 plus 1 9, 94 square centimeters is the TSA of a cuboid, of the given cuboid. Similarly, find LSA of a cuboid. LSA of a cuboid, the formula it is 2H into L plus B square units. Now substitute those values. That is 2 into height is equals to what? 3 centimeters into length is equals to what it is? 5 plus breadth is equals to what it is? 4 square centimeters. That is 2 into 3 6 plus 5 into 4 is equals to 5 fours are 2 into 6 3 is equal to 6 into 5 plus 4 is equals to what? 9 square centimeters. 6 into 9 6 nines are 54 square centimeters. 54 square centimeters. Like this we will find the LSA of a cuboid. Just write the correct formula, substitute the correct values and simplify. We will get the TSA of a cuboid as 94 square centimeters, LSA of a cuboid as 54 square centimeters. Is it clear, children? We will discuss an example for what a cube. Now we will discuss one more example. Find the TSA, that is total surface area, and LSA, that is lateral surface area of a cube whose edge is 4 centimeters, whose length of the edge is 4 centimeters. So for here cube it is given L is equals to 4 centimeters. TSA total surface area of a cube is equals to 6L square units is the formula. That is 6 into L is equals to what? 4 square centimeters. That is 6 into 4 square is equals to 4 into 4 16 square centimeters. That is 6 into 16 or 16 into 6 16 6 are 96 square centimeters. So total surface area of a cube is 6L square units. 6 into L is equals to 4 centimeters. 4 square is equal to 16. 16 into 6, it is 96 square centimeters. Now LSA of a cube. LSA of a cube is equals to 4L square units. That is 4 into L is equals to 4, that is 4 square centimeters, which is equals to 4 into 4 square is equals to 16 square centimeters. Now 16 into 4, 16 4s are 64 square centimeters. Like this we will find the total surface area of a cube and lateral surface area of a cube using the formula 6L square and 4L square respectively. Is it clear, children? Yes. Now find the TSA total surface area and CSA curved surface area of a cylinder with radius 7 centimeters, base radius is 7 centimeters and height is 40 centimeters. With base radius is 7 centimeters and height is 40 centimeters. Find the TSA and CSA of a cylinder. So it is given radius R is equals to 7 centimeters and height H is equals to 14 centimeters. Now TSA of a cylinder. TSA of a cylinder is equals to 2 pi R into R plus H square units. So write the correct formula. So TSA of a cylinder is 2 pi R into R plus H square units. That is 2 into pi is equals to 22 by 7. So here we use pi is equals to 22 by 7. So 2 into 22 by 7 into radius is equal to 7 centimeters into radius R is 7 plus height it is 14 centimeters. That is square centimeters. Now 7 ones are cancelled. Then 2 into 22 it is 44 into 7 plus 14 is 21 square centimeters. Now you multiply this 44 into 21. 1 4s are 4, 1 4s are 4, 2 4s are 8 and 2 4s are 8. It is 4 plus 8 12, 8 plus 1 it is 9. 924 square centimeters. 924 square centimeters is the TSA of a cylinder. Now CSA of a cylinder, that is curved surface area. CSA of a cylinder. CSA of a cylinder is equals to 2 pi RH square units is the formula. That is 2 into 22 by 7 into R is equals to 7 and height is equals to 14 square centimeters. 7 and 7 cancelled. Now 2 into 2 it is 44 into 14 square centimeters. Now multiply. 14 4s are 56, 6 and 5 is there. 14 4s are 56, 56 plus 5 it is 61. 616 square centimeters is the curved surface area of the given cylinder. So like this we use the correct formulas and correct values. If you substitute and simplify, we will get the correct areas. Is it clear, children, how to find the CSA and the total surface area of a cylinder? I hope you understand today's concept, that is surface areas of solid shapes, especially cuboid, cube, and it is cylinder. So with that we solved some of the problems, and your homework is exercise number 11.3, question number 1 and question number 3. This is your homework. Thank you very much.